Okay, everybody, this is your instructor. Let me make sure I'm not in the way so you can see. In this video, we're going to go over the practice test for Test 2. Recall that Test 2 will be taken in class in our regularly scheduled classroom from 1 to 3 on Friday, August the 10th. So that's a week from today. And also, to go over this practice test, you might want to get the following documents ready and printed that are available on eCourse. First, the practice test for this is for Test 3, practice test for Test 3. So it's Test 3, not Test 2, that's on Friday, August the 10th. Sorry about that. If you cannot hear me very well, then please just turn up the volume on your computer so you can hear me fine. If I'm too loud, then please turn down the volume to the appropriate level that's comfortable for you. Okay, so you might want to make sure you have a copy of the practice test for Test 3. Get yourself a copy of the cheat sheet for Test 3. Notice that the first 7 pages of the cheat sheet for Test 3 are for the first 8 problems on the practice test. That covers chapters 16, 20, and 21. So the first 8 problems on the practice test are the first 7 pages of the cheat sheet. The rest of the cheat sheet, starting on page 8, where it says Handout over Hypothesis Testing in chapter 23, part 1, from there till the end, those are all the handouts that are associated to just the last 2 problems on the practice test, problems 9 and 10. And a lot of these are tables and flowcharts that I have taken from another book, from one of the other classes I've taught, that give you a step-by-step method that's easy to follow, that tells you how to do a hypothesis test. So the first 7 pages of the cheat sheet are for the first 8 problems on the practice test, and then the last pages of the cheat sheet are just for problems 9 and 10. I also have a copy of the solution key to the practice test for Test 3, which is also on eCourse, and you can also have this out and be referring to this as we go over the problems, since all the major calculations for the problems on the practice test are worked out in detail in this document, the solution key to the practice test for Test 3. Okay, so let's go ahead and get started. We'll start with problem number 1 on the practice test. And the given information for problem 1, for all parts of problem 1, is that of all Americans, it says type O blood is the most common blood type. We're told that 44% of all Americans have type O blood. Did that make it into the viewing rectangle? Have type O blood. Let's see. There we go. Well, I'm going to have to rewrite. We have a limited window here, so I'm going to have to write a little smaller. Given 44% of Americans have type O blood, and 4% of Americans have type AB blood. So type AB blood is the least common blood type, and type O blood is the most common. And these are the percent breakdowns for both blood types. So that's given in the problem. Now we move to part A. It says, what's the probability that a randomly selected American citizen will have type O blood? So if we randomly select an American citizen, what's the probability they will have type O blood? Then it says, is this an example of the relative frequency interpretation of probability or the personal interpretation of probability? Recall that from the book in chapter 16, there's two major interpretations for probability. One's based on relative frequency of occurrence, and the other's called personal interpretation. Okay. Anyway, so for this particular one, we notice that we're given the relative frequency as a percentage for type O blood. So based on relative frequency, interpretation, this would say that the probability that a randomly selected American has type O blood is the relative frequency of occurrence written as a proportion. So all we have to do is take the given relative frequency as a percentage and just divide by 100 or move the decimal place 2 places to the left, and the probability then becomes 0.44. So the answer to part A is probability equals 0.44, which is the relative frequency of occurrence for type O blood, and that's based on relative frequency interpretation. And part B says, what's the probability that a randomly selected American will either have type O blood or have type AB blood? Recall that anytime you see a probability statement or question that involves either one event occurring or, the word or is in there, some other event occurs when you perform some procedure, those are called compound probabilities. The clue or the litmus test that tells you that's a compound probability is the or. Saying, what's the probability a randomly selected American either has type O blood or type AB. So we could write this probability in the notation, probability that either the event E occurs or the event F occurs when we perform the underlying procedure, which is to randomly select an American and check their blood type. So we have a compound probability. What's the probability that either the event E or the event F occurs after performing the underlying procedure? So if we go to our cheat sheet, we see that we have two choices for how to compute probabilities, compound probabilities like this that have an or in them. We can either use Formula 1C from the cheat sheet that says the formal addition rule for mutually exclusive events, or we can use Formula 1D, which is the general formula for the addition rule for non-mutually exclusive events. So before we figure out whether to use Formula 1C or 1D, we have to decide whether or not the event E and the event F are mutually exclusive events or non-mutually exclusive events. E would be what? The event of obtaining type O blood. And F would be the event of obtaining type AB blood. Now, if you think about it, to be mutually exclusive means that two events cannot occur simultaneously. If you randomly select an American citizen, can that citizen both have type O blood and have type AB blood at the same time? And the answer is no. Every person only has one blood type, either type O, type A, type B, or type AB. It's not possible for a randomly selected American to have both type O blood and have type AB blood at the same time. So that would say that the events E and F are mutually exclusive events. So what that means is we have to use Formula 1C from the cheat sheet, the formal addition rule for mutually exclusive events. And what that says is the probability that E or F occurs is the probability of E occurring plus the probability of F occurring. Now, The probability of E occurring is the probability that a randomly selected American has type O blood. The probability of F occurring is the probability that a randomly selected American has type AB blood. And we can find both of these probabilities from the given relative frequency information for type O and type AB blood. Based on the given relative frequency breakdown for Americans that have type O and Americans that have type AB blood, we know that the probability of E is 0.44, and the probability of F, which is having type AB blood, is what? 0.04. So, using the relative frequency interpretation together with this addition rule for mutually exclusive events, we get that the desired probability is 0.44 plus 0.04. And that equals 0.48. So the answer to part B, if you can see it, sorry. The answer to part B is 0.48, which is 0.44 plus 0.04. Sorry, it's moving around a little bit, but like I said, we have a limited window here. Hold on. There we go. Okay, I'm going to go ahead and erase the board now and do part C and D. So, going on now to problem 1C. The practice test says, what's the probability that a randomly selected citizen will have a blood type that is different from type O blood? So if we say let E equal the event that we obtain type O blood, let me move this. I got off course here. Type O blood. Then we have two ways of doing this. What we want is not the event that we obtain type O blood from randomly selecting an American citizen. We want the event, the probability that the randomly selected American has a different blood type than type O. We can do this in one of two ways. We can note that E complement, which is the complement of the event E, is the desired event. It's the event of not obtaining type O blood, which is what we want. We want to know the probability that a randomly selected American does not have type O blood. And if we want that probability, we can compute that directly from the probability of the event E occurring using what's called the complement rule. So one way to do this is to note that we want the probability of E complement, where E is the event that we do obtain type O blood. And that formula, the complement rule, is formula 1B. Formula 1B. So if we use that, we could say that the desired probability, which is the probability of E complement here, is just 1 minus the probability of the event E occurring. And since we've already computed the probability of E, or found the probability of E to be 0.44 in part A of this problem, then the probability of E complement would just be 1 minus 0.44. And that is 0.56. So the answer to part C for the probability that a randomly selected American has a different blood type than type O would be 0.56. Let's make sure that got in there. It did.